This time, Year 10, we're going to look at a GCSE Required Practical. We've covered this already in part of a previous video lesson, but today I'd like to show you a video of the specific steps. So the Required Practical is titled Preparation of a Pure Dry Sample of a Soluble Salt from an Insoluble Oxide or Carbonate using a Bunsen burner to heat dilute acid and a water bath or electric heater to evaporate the solution. So just to remind you, there are several types of neutralization reactions that you need to know about. You need to know about an acid plus a metal oxide, otherwise known as an insoluble base, will make the corresponding salt and water. You also need to know that an acid plus an alkali, typically a metal hydroxide, will make a salt and water, as well as an acid plus a metal carbonate, and that's another sort of insoluble base, but it's a special class of insoluble base known as a carbonate. Remember that 8 means it contains oxygen, so typically it's MCO3 or something along those lines. Those two will react together to form the corresponding salt, water and carbon dioxide. And lastly, the first example that we looked through was an acid plus a metal makes the corresponding salt and hydrogen. This is the only case where something other than water is formed. You form hydrogen instead of water. And the practical, the required practical could ask you about any of these reactions. And typically, they like to ask 6-mark questions about these required practicals, as we saw in our last video lesson. Today we're going to make copper sulfate. We've got some sulfuric acid here in this beaker, which is on a tripod and a gauze. So I'm using 1 molar, 1 mole per decimeter cubed of sulfuric acid. And to it, we're going to add copper oxide. So this is a simple acid-base reaction. Sulfuric acid and copper oxide makes copper sulfate and water. So the particular reaction that I've chosen to look at today is sulfuric acid plus copper oxide makes copper sulfate and water. And what I've done here is I've obviously put the balance symbol equation underneath here, but I've tried to sort of colour code them to make this more straightforward so that you can sort of understand and appreciate what's going on. So you've got sulfuric acid, which is colourless. There's a bottle here that you'll see from the video. And copper oxide, which is a black solid, right? Remember these state symbols. AQ means aqueous, dissolved in water. S means solid. So sulfuric acid is aqueous, it's dissolved in water and is therefore colourless. Remember, it's not clear, just clear, or white. It's not white, it's colourless. And you've got copper oxide, which is a black solid. And when you dissolve your copper oxide in sulfuric acid, you'll form copper sulfate, which is aqueous, again dissolved in water. You can see here a solution that we've made of copper sulfate in this reaction. And you also form water, which is a liquid and is colourless. To begin with, in the first step, let's do the reaction. Let's warm up the sulfuric acid and then slowly add the copper oxide so it dissolves and then it will be in excess. So here we go, about to just warm the sulfuric acid on a medium flame. There we go, so we'll get it warm and bubbling. And then we're slowly going to add the copper oxide. Begin with just 1 spatula full. And I'll use a stirring rod to gently stir it.
And the key thing with this reaction is to warm the sulfuric acid. We don't want it to boil for safety reasons because we don't want it to split. So at the moment it's bubbling at the top. Bubbling is okay provided it's not too vigorous. We're just warming it gently. Give it a bit of a stir. And as the reaction takes place, you might notice a colour change. For those of you who are very observant will notice that at the top, it's starting to change colour. We're looking for a beautiful blue solution, which hopefully you can just about see starting to happen now. Just going to move the Bunsen away and pop it onto the safety flame. You can see already we've got that nice blue colour appearing. Let's give it a bit of a stir. Make sure that the copper oxide is properly mixed with the sulfuric acid, and then we'll pop the Bunsen back underneath. Hopefully what you can see at the bottom as well is that the copper oxide is slowly dissolving, hence why that blue colour is starting to appear. Give it another stir to mix in the excess copper oxide, and what we want here is we want all of the copper oxide to dissolve. Stir. All of the copper oxide is now dissolved, so I'm going to remove the Bunsen and pop it back onto the safety flame, because we'll need that later, and I'm going to add some more copper oxide. The purpose of adding extra copper oxide, and there you can see it fizzing away because it's nice and hot, the purpose of adding extra copper oxide is so that it's in excess, so that we know that all of the sulfuric acid has reacted. So I'm just going to leave that to cool, and then the next stage is that we will filter the solution to remove the
excess copper oxide. Okay, now that the reaction's complete, we're going to filter the solution. So I'm going to take a filter paper, which I'm going to fold in half, and then fold in half again into quarters. And then I'm going to place the filter paper, once I've opened it out, into my filter funnel and a conical flask here. And I'm going to pour in my copper sulfate solution. You can see the excess copper oxide at the bottom there. So let me just adjust this. Hopefully you can see that okay. I'm going to pour in the copper sulfate solution to remove it from the excess copper oxide. And you can see in the beaker there's plenty of copper oxide in there. And now that it's filtered, we've got a beautiful blue copper sulfate solution. We've now set up a water bath, so in here in a 250 milliliter beaker, I've put in some water, and in the top we have an evaporating basin. So I'm going to take the copper sulfate solution and pour that into the evaporating basin and allow the copper sulfate solution to evaporate. And here you are, hopefully you can see the solution is starting to evaporate, the water is evaporating out of the solution, and ultimately what we'll be left with is crystals of copper sulfate. So you want to heat it until you've got about a third of the original volume of copper sulfate. Then we're going to turn off the Bunsen, let it cool, and place the crystals, or rather the solution, on the side to crystallize. And so this is the end result. Beautiful crystals of copper sulfate. This is a few days later from the original video. Beautiful shiny crystals of copper sulfate. And the next stage is to dry them off by patting them down with some tissue paper and putting them in an oven to dry completely, so that we've got a clean, pure, dry sample of copper sulfate. So here is our chemical oven at school. I'm going to open the door here, place our evaporating basin inside, and leave them to dry. So just to summarise, guys, these were the steps that we've seen. We heated up the acid, we slowly added the base, in our case copper oxide, in our case sulfuric acid, and we stirred until there was an excess of the metal oxide, the hydroxide or carbonate. Remember, it could be any of those and it could be any acid. You need to be able to work out what acid would be required, what metal or metal oxide or metal hydroxide or metal carbonate. So you should see an excess in the bottom here. That's how you know that all of your acid has reacted. In the next step, you then filter the mixture. So you're removing the excess of the metal or metal oxide or metal hydroxide or metal carbonate, so that you've got a solution of your salt, the thing that you've been wanting to form, and you've left the excess solid behind in the filter paper. Then lastly, you heat over a water bath until you've got about a third of the original solution. I would slightly disagree with this particular image here, which suggests that you just heat until you've got solid crystal remaining. You don't want it to spit out, which it can do as it gets very hot, so that you lose material, which is really why you use a water bath in the first place. So these are the key points really from this particular reaction in terms of a required practical. In terms of the reaction, you gently warm the acid to avoid spitting. Again, we've talked about this, you don't want to lose material, that will affect your yield. You want an excess of the base or the metal, and that will make sure that all of the acid reacts. In terms of filtration, the filtration steps needed to separate the excess base or metal from the salt solution. And then in terms of evaporation, you remove the water via evaporation. You gently warm the solution, again to avoid spitting, loss of product, hence why you use a water bath or an electric heater. And then you crystallize the salt by leaving the remaining solution on the side, so that the last little bit of water can evaporate slowly and leave you with nice large crystals. And the final step is to make sure that those crystals are nice and dry, either with patting it with a filter paper to ensure that it's dry, or to place it in a warm oven, as we saw in the video this time. Thank you ever so much for listening. I hope that this video has been useful to you. Please leave a comment if you find them useful or you want me to include something else or do something differently. The next required practical will be on electrolysis, and I'll create a playlist specifically for these required practicals that you can access, which will be really helpful to you in the run-up to your exams. Thanks ever so much for watching, guys. See you next time.